I work at Oracle, so I'm very much focused on server virtualization and server operating systems. The products in my org are Oracle Linux, Oracle VM, both x86 and Spark Hypervisor, Oracle VM VirtualBox, the client virtualization solution, and Secure Global Desktop. On the Linux side in particular, we spend a lot of time optimizing memory access. We spend a lot of time making sure that Linux can scale to larger and larger numbers of cores. And we have to make sure that the I/O layer is highly optimized to be able to deal with this fast storage. Right? And so in particular, when we talk about, we go from rotational devices to now flash devices, there's a big difference in how you access them. For the last several years, developers working on Linux, and some people in my group, but also people in other companies, right, have been working on making file systems be able to handle being a file system on a solid state device, or having the block layer be able to handle directly mapping memory to flash devices. We have two models of working with flash. We can use flash for storage, and the other one is to extend the memory of a system. And we have a feature called Oracle Database Smart Flash Cache. And what that does is it allows us to take a flash device and sort of extend the database memory footprint to be larger. This flash device then gets used as sort of a read-only extra amount of memory, which is obviously much faster than going down to disk. 8-9 years ago, we had to start building a closer relationship with the card vendors, with the I/O controller vendors, and so forth. The relationship with LSI has changed from working together from a product management point of view to actually having developer relationships. The ability to have access to early hardware is important because we want to be able that when you ship a new product, that we can support that out of the gate. Given that you're providing solutions for application acceleration with a Nitro card, that means we have to do development on a file system. We have to do development on the block layer. And so it's very difficult to give a hint to the storage when the blocks are everywhere. It's a little bit easier when we look at storage as a device, and we can say, this range of blocks is important to keep in the front end and keep hot in the cache, and the rest of the content is just stuff that we might read tomorrow or next week. We look at the server side. Obviously, CPUs are getting faster, more cores per socket, more memory per socket, and more memory per system, and because of that you run larger applications. When you run larger applications, you typically have more data. We need access to larger amounts of data. A terabyte is nothing. A terabyte is a tiny database today. We're looking at many, many, many terabytes of storage for even a single database environment. Our job is to provide the fastest access to whatever they need. Storage, memory, number of CPU threads, and so whatever we can make use of, we will and want to make use of.